Let's talk about the uses of group 2 metals. And the metals they're mostly interested are magnesium, barium, and calcium. So in terms of when we look more closely at these, magnesium's role will be in the extraction of titanium and also in its role as an indigestion treatment or medicine. For barium, again, it will be medicine, but this time in imaging. So that will be your barium meal. And then we'll be talking about the use of barium chloride as a test for sulfates. And then in terms of calcium's role, we'll be looking at its role in agriculture to neutralise acidic soils, and then also in its role in industry, removing sulfur dioxide from flue gases. So obviously we need to talk about this in far more detail, but this is the whole blurting type of revision technique where you learn all the content but then make sure you've got an idea of the bigger picture, so that if someone mentions magnesium, okay, fine, I need to know that it's to do with titanium extraction. It's used as an indigestion medicine. Barium, oh, fine, that's to do with medicine. Imaging, looking at the digestive system. It's used as a test for sulfate ions, and then calcium is used in agriculture and industry in order to remove acidic oxides as well as neutralising acidic soils. So those two roles are quite tightly linked. So now let's go into the in-depth chemistry. So starting with magnesium. We already mentioned its two roles. Titanium extraction. As an indigestion aid or medicine. So titanium is a really useful metal. We like using titanium because it's strong, it has low density, it's highly resistant to corrosion. Now, in terms of extracting titanium, purifying it, unfortunately, remember with extraction of metals, it totally depends on the reactivity of the metal. But if it's very unreactive, such as gold and silver, it's found native, Lyra, in the Earth's crust. If the metal is less reactive than carbon, then you can basically use a blast furnace, such as in the case of iron oxide, and you use carbon monoxide to reduce that iron oxide to make iron. And then if it's more reactive than carbon, then you have to use the expensive electrolysis process, but that's super annoying because you've got high energy costs. Now, titanium isn't particularly reactive, so you would expect to use this process, you'd expect to use reduction with carbon, but unfortunately, when you react it with the carbon, it forms titanium carbide, which is very brittle. So let's make the note, titanium can't be extracted by reacting with carbon because titanium carbide is formed, which is very brittle. So that means it breaks very easily when a force is applied. So therefore, in terms of how you actually go about extracting titanium, it's in the following steps. And obviously one of those steps must involve magnesium, because after all, this part of the specification is all about the uses of group 2 elements. So first of all, you treat the titanium with chlorine to form TiCl4. And then this is where the magnesium comes in. The magnesium is used to reduce TiCl4 in the following equation. And you do have to learn these equations. Let's check that reduction taking place by looking at the oxidation numbers, oxidation states. So this chlorine here is -1, which means that titanium is +4, and the titanium on the right-hand side is 0, hence reduction has occurred to that TiCl4. Look at the oxidation states of magnesium, where you've got 0 over here, -1 for the chlorine, which means that must be 2 plus 2 for the magnesium. So here we can see oxidation taking place. So just to really point that out, the magnesium acts as a reducing agent. By definition, remember, reducing agents are always oxidized, which we can see has taken place here. So magnesium acts as a reducing agent. It has caused TiCl4 to be reduced. That's enough on titanium. Now let's talk about the role of magnesium as an indigestion medicine or treatment. So you need it in the form of magnesium hydroxide. So magnesium hydroxide is used to neutralize excess stomach acid, which remember is hydrochloric acid. The reason it can be used like that is because the magnesium hydroxide is insoluble. So if we look at the equation of what takes place, it's just a generic neutralization reaction which produces magnesium chloride and water. Make sure it's balanced. In this form, this medicine is known as milk of magnesia. And just to point something out, remember carbonate would also work. So for example, if we were to take magnesium carbonate, effectively you'd also get a neutralization of that hydrochloric acid, but the issue here is that you produce carbon dioxide, which remember is a gas. So that produces lots of bubbles, which, let's be honest, if you've got a bubble party happening in your stomach, that's not going to make you feel any better. So our go-to remedy is milk of magnesia. So that's magnesium done. Let's move on to barium. Let's start with its medicine role. Now, in its role in medicine, it's barium sulfate, BaSO4, and again, its use relies upon it being insoluble. So barium sulfate is known as a barium meal, and what's cool about it is that it absorbs X-rays to give an image of the gut, so you can see basically if there are any blockages or not. Now the key thing here is that it's insoluble, which means that although usually barium compounds are highly toxic, because it's insoluble, they're not absorbed into the body. Now we'll look at the second role of barium, which is that it's used to test for sulfate ions. You might have met this at IGCSE and GCSE. So what is the test for sulfate ions? Well, you need acidified barium chloride, and then the positive test for sulfate ions with that barium chloride is a white precipitate. And if you were to look at the ionic equation, you've got those barium ions reacting with the sulfate ions to form barium sulfate, which is a white precipitate, a solid. So this is insoluble again. Remember that we need that acidification with something like hydrochloric acid in order to react with any carbonate ions which could interfere with the test and produce carbon dioxide. So that acid reacts with any carbonate ion impurities. And then lastly, calcium. Let's divide its uses into agricultural uses and industry uses. So in agriculture, calcium hydroxide is known as slaked lime. It's added to acidic soils in order to neutralize them so that pH is increased and that helps crops grow, because crops really don't like acidic soil. What about the industrial use of calcium? Well, this is in the form of calcium oxide and calcium carbonate. These are used to remove toxic SO2 gas from factory chimneys. And I'll just show you some equations. So here's the first equation with calcium oxide, and now we'll look at when calcium carbonate's used. Some past paper practice. There are many uses for group 2 metals and their compounds. State a medical use of barium sulfate. State why this use of barium sulfate is safe, given that solutions containing barium ions are poisonous. So the use is as a barium meal. And why is it safe to use in this way? Because barium sulfate is insoluble. Magnesium hydroxide is used in antacid preparations to neutralize excess stomach acid. Write an equation for the reaction of magnesium hydroxide with hydrochloric acid. So here is your formula of magnesium hydroxide. Remember, magnesium is 2 plus, hydroxide is OH minus. There's hydrochloric acid. It makes MgCl2 plus H2O. Get that balanced. Solutions of barium hydroxide are used in the titration of weak acids. State why magnesium hydroxide solution could not be used for this purpose. Again, because it's insoluble. You can't be titrating something that's insoluble. Magnesium metal is used to make titanium from titanium 4 chloride. Write an equation for the reaction of magnesium with titanium 4 chloride. So this is what I was saying in the video, you do have to learn this. And then again, make sure it's balanced.